sample problems. Okay, let's find the molar mass of these compounds. Now, in order to do that, we need the periodic table. So I have one of those handy, and I'm going to need a calculator. I have one of those handy right here. I'm going to maybe move that a little bit. Whatever. So you can see behind it molar mass. Okay, but it's up and out of the way, and I'm going to show you exactly how I would calculate these molar mass problems. So I have my pen ready. So I know that this is made up of carbon and oxygen. Carbon, how many of them are there? CO2. There's one atom of carbon, or 1 mole of atoms of carbon. And how many moles of atoms of oxygen are there? There are 2 moles of atoms of oxygen. And then we're going to take that and multiply it by the mass on the periodic table. Now, we just did this to find that the mass of carbon on the periodic table is 12.011. And we just figured out that the mass of oxygen was 15.999. Now, this is a different compound that we did here. That was carbon monoxide. This is carbon dioxide. And so now we can plug this in the calculator. 12.011 plus 2 times 15.999. And when we do that, we get, when we add that up, we get 44.009, and the units on that is grams per mole. So now here's something a little bit bigger. Here is sodium acetate. How many sodiums do we have? We have 1, and then we'll have to look that up, what the mass is on the periodic table. And then carbon, how many carbons do we have? We have 2 times, and we know that one already from up here, so I'm not in the market of doing a whole bunch of extra work. Okay, and then we have hydrogen. Hydrogen, there's 3 hydrogens. We have to look that one up. And then oxygen is 2 times, and we already have that one, 15.999. And you'll find, or at least I find, that I get to know the masses on the periodic table because I calculate molar mass so much. Okay. So we need sodium and hydrogen. Sodium has a mass of 22.990, and hydrogen has a mass of 1.008. Okay. So this is going to be 22.990 and 1.008. So we're going to plug this in the calculator. Okay, 22.990. Now that is going to be added to 2 times 12.011 plus 3 times 1.008 plus 2 times 15.999. And when we do that, we get a molar mass of 82.034 grams per mole. Okay, that's pretty good stuff. Maybe you try the last one on your own, and then I'll do it, and then you can see if you got it right. Okay, I say okay a lot in my videos. That's weird. So let's start. This is calcium phosphate. Now this has these parentheses in here. Parentheses in chemistry are similar to parentheses in math. What we can do is distribute by multiplying the values through here. So let me do this. It'll be calcium. How many calciums are there? 3. Now phosphorus. There's 1 here, but the 2 distributes, so that's going to be 2 phosphoruses. And then the oxygen, that distributes here, so there's 2 times 4 is 8 oxygens. What we're saying is that there's 2 of this whole unit. There's a PO4, and then there's another PO4. So that means that there's 2 phosphoruses 108 oxygens. That is a very big source of confusion for students studying chemistry. Sometimes they add, and that's not what we want to do. Now, calcium, we don't know. Phosphorus, we don't know. We'll look that up on the periodic table. Oxygen, we know, 15.999. So the periodic table, we need calcium and we need phosphorus. Calcium is 40.079. Phosphorus is 30.974. 078 for calcium, 974 for phosphorus. So calcium is 40.078. Phosphorus is 30.974. Okay. Now we take those, we add them up. We multiply and add them up. So let me clear my screen. And we'll get this. 3 times 40.078 plus 2 times 30.974 plus 8 times 15.999. That equals 310.174. That is awesome. That's grams per mole.